All right, we're in chapter 7, and this is section 7.6 on rational equations and formulas. All right, so our objectives here are solving rational equations, then recognizing rational expressions and equations, finding graphical and numerical solutions, solving a formula for a variable, and finally solving applications involving rational equations. So rational equations. Well, if an equation contains one or more rational expressions, it's called an irrational equation. And so an equation, remember, has equals. Okay. So if it has more than one rational expression, then it has equals between them, then it's going to be a rational equation. And usually it's like A over B equals C over D. Now, they can be solved by doing the cross product. Okay. So basically we're going to take A times D equals B times C. And that's usually the easiest way to solve those. Now here, B and D have to be non-zero again because we can't divide by zero. And so what we're doing is we're converting a rational equation into one that we can easily solve in normal ways. Okay, so it depends on what the variables are, what the numbers are. We can usually solve that pretty easy. So for example, we want to solve these equations. Well, we're just going to take 9 times x, and that's going to equal 7 times 4, and then we're going to solve for x. So how do we do that? Well, we take 9 times x is 9x, 4 times 7 is 28, divide both sides by 9, and we get 28 over 9. Now here, this one, we have to think about that as x over 1. So now we can take 6 times 1 is equal to x times 2x plus 1, and so when we do that, we're going to have the following. Now we have to distribute. So we're going to have to take x times 2x, so that's going to be 2x squared plus x equals 6. Now, are we done? No. What we have to do is we have to take that 6 to the other side. So we subtract our 6, and now we have a trinomial. Now we have to decide, can we factor the trinomial and then use the zero product rule to solve for x? Well, we can factor that one. That's just 2x minus 3 times x plus 2. Now we set each of these factors equal to 0 using, again, the zero product rule. And when we do that, if we set that equal to 0, we take the 3 to the other side, we'll have 3. Divide by 2, we'll get 3 halves. We take the here, that to the other side, we get x equals a negative 2. And so, again, showing that as we go, those are going to be our two solutions, minus 2 and 3 halves. Okay. Now, a key to a lot of these problems is we should probably usually check and make sure that that's going to work and make sure we don't get a 0 in the denominator. So if we plug in the 28 over 9, we're not going to get 0 in the denominator. So we should be okay there as long as we did all the math right. And so if we have 4 over 28 over 9 multiplied by the reciprocal 9 over 28 and 9 over 28. The denominator is 1. Now we have 4 goes in here once, 4 goes in here 7, 9 sevenths. So that really is the solution. Now they're not showing this, but this is really something you should do. Now if we plug in negative 2 here, negative 2 times 2 is going to be negative 4 plus 1. That's going to be 4 plus 1 is going to be minus 4 plus 1 is minus 3. And then we minus 3 goes into that. That's going to give us a minus 2. Well, if we plug in minus 2 here, we get a minus 2. So that one works. And here we have a 3 halves times that. So if we take 3 halves times that, well, the 2's cancel. We have 3 plus 1 is going to be 4. So we have 6 over 4 equals 3 over 2. Well, we can divide by 2 and we get, oops, 3 halves on both of them. So that one works as well. So checking your answers is always a good thing. And so that's something that they didn't show in this example here. All right, so let's stop there and we'll come back for some more.